Hi everyone, welcome to the DataHour series. We are thrilled to be with you here this evening, at least in India, it's evening right now, for a session full of value-added learning and some tangible benefits that you can get from it. My name is Purva Hulgul and I'm a product manager at Analytics Vidhya. On to our presenter today. I'm delighted to be joined by Andrew Engel, who is our presenter. Andrew is the chief data scientist at Rasgo. He has been working as a data scientist and leading teams of data scientists for over a decade in a wide variety of domains from fraud prediction to marketing analytics. Andrew received his PhD in systems and industrial engineering with a focus on optimization and stochastic modeling. He has worked for Towson University, the SAS Institute, the US Navy, WebSense, which is now ForcePoint, Stix, HP, and has also led data robots efforts in entertainment, sports, and gaming before joining Rasgo in 2020. Hi, Andrew.
Hello, thank you for having me. Hello, everyone. I'm glad you're here. For those of you who attended my presentation last week, this is going to be a more practical version of that discussion of advanced feature engineering best practices. So we're not going to use slides. Hopefully at this point, between the person who kindly shared the notebook on Drive and the people who were able to pull it down from GitHub, we have this document. We'll be walking through explaining this and really explaining my approach to building features for model. A couple of notes about this document. You may know there are empty blocks for text. This was designed to allow you to take notes in it as I go. But also, I have a fully written out version of this notebook. I will replace this particular notebook with all of my notes by the end of day today. So if you come back tomorrow, re-download it, you should have my explanation of what we're seeing. And then as a note, this repository that holds this notebook contains a lot of additional examples of Python code to do various different things, from this feature engineering, including categorical features, which we'll hit on a little bit about model training and model selection, feature importance and feature selection. So there's a lot of additional things here that you'll be able to take a look at and explore. And this is all open source, and I welcome any additional help or suggestions or questions about this repository. So with that, let's get started. We're going to start relatively simple with just a few packages within Python. We're of course going to use NumPy and pandas. We'll use the one-hot encoder from scikit-learn, and then we'll use a product also supported from scikit-learn, an extension called category encoders, to talk about other ways to handle categorical variables. So we'll get started by importing those. And then we're going to work on customer churn data. So this customer churn data is stored in my personal repository. This is made up data. This is artificial, created for the purpose of this presentation. So you're welcome to use it. It's freely available. Don't take anything in it as the truth about the way customers behave. You should be able to build a model with it. I have not, so I don't know exactly how good of a model you can build. But we're going to pull that data into our notebook environment. We have two data sets. One, a customer data set, where you can see just basic information about the customer, an ID, their gender, their birth date, where they live in the United States, a phone number, and whether or not they churned and what day that churn occurred on. We're not going to talk about how you define churn. That's the topic for another presentation. We're just going to assume that the people who held this data identified the last transaction before a customer churned.
Andrew, just a small request. Could you please zoom in on your screen, because I think the font is slightly small for the people who are seeing the screen.
Better? Is that size okay? Yep, okay. Let's look at the transactions. Very simple transaction data. We have a transaction ID, the date on which the transaction occurred, what product was purchased, how many of those products were purchased, and how much. You can think of this as the purchase price, so the total amount spent. So the first thing I'd like to do is I'd like to look at customer behavior, or I'm going to assume that when we do this churn prediction, I want to make a prediction every time a customer makes a purchase for how likely they are to churn in the next so many days, say next 30 days. So each time they make a purchase, I need to aggregate all of the data up to and including that purchase to capture how the customer has behaved. There's a number of ways we can do that. We can build everything the customer's done over their entire lifetime, but it's often nice to look at certain time windows in the past. So I may be interested in what has the customer done in the last 30 days, or what has the customer done in the last 90 days, or in this case, I'm doing what has the customer done in the last 180 days. And Pandas makes this really easy through the use of their rolling aggregation method. So we're going to create a rolling group on transactions, just to make sure things are in the right order when we actually do aggregations, and make sure we're sorted by customer and transaction date. Now, I set the index to be that transaction date. It's not strictly necessary. I just like it because it makes my code a little bit cleaner to know that I'm doing a lot of this work at the date level. And then once I have my index at that date level, I want to create a second group on the customer ID. And so I now call rolling. Rolling takes two kinds of values. So in this case, I'm creating a rolling on 180 days because I've set the index to the transaction date. You can tell rolling to calculate this on 180 days by telling it what the date column is. Alternatively, I could say 180, and rolling would simply look back at the last 180 observations, ignoring the date. That's absolutely valid. If I was doing this for real, you would see a sequence of these. I'd probably do rolling over the last 30 days, rolling over the last 90 days, rolling over the last 180 days, depending on how my data actually looked. But I'd also do rolling over the last 2 or 3 transactions, rolling over the last 5 transactions, rolling over the last 10 transactions, regardless of how long it was. And then I control these windows by closed. So what this is saying is, do I want to include the left-hand side, so the transaction on the earliest possible date, 180 days from the current date, and on the right-hand side, do I want to include the current transaction? And in this case, because I'm assuming the customer has made this transaction, I'd like to include both of them. And then we're going to simply create a bunch of new fields, which says, okay, what is for every single customer on a given transaction, the minimum amount they spent over all transactions that occurred in the last 180 days? What's the maximum amount? What's the average amount? What's the standard deviation? And what's the total amount? So we can do that. And then in addition, I'd like to simply know how many transactions has the customer made in that same time window. And so if we take a look, since I know there were some questions about exactly what this is doing, we can take a look at this individual customer, their very first transaction. We see up until this point, everything to the left is individual transactions. And we can see, well, everything has to be based on that single transaction. If you look at the next transaction, that definitely occurred in 180 days. And now you begin to see we're calculating those aggregations over these two transactions. And then when you go to the next transaction, it's over these three transactions. So we're slowly building up that picture of how does the customer behave on average? Because what I'm really interested in is what is the average behavior of the customer and how does that change? So if I was doing this for real, as I said, I do this over multiple different aggregations, time windows, transaction counts. But one of the things I want to highlight is I don't have to do this at the customer level. I can do this at other levels. And this is a really powerful way to handle categorical variables. If I look at this, the product is a categorical variable. But if I think about this transaction 3, the customer purchased A, how does that compare with prior products they've purchased? And there's a number of ways to do that. We can calculate counts of the various products, pull that in. But one of the things I could do is ask, what does the average purchase of people who purchased product A up to this point look like? So I can do these same aggregations at the product level. Now, this is a little bit trickier simply because rolling has some interesting behaviors. So let's ignore the first few lines and let's talk about this product window 180. It's very similar, except I'm doing it at individual product levels. I'm sorting by the transaction date. I'm creating that same index, and now my rolling goes back 180 days, but you notice it's closed on the left. So what that's saying is I want this to be closed on the first transaction in this time window, but I don't want to include the current transaction. Now, why is that? That's because when you begin dealing with dates, it's very easy to build variables in modeling that you don't actually have access to in production. Why is that the case here? Well, I have lots of customers making purchases. Odds are I'm going to have multiple customers making purchases on the same day. This data, as oftentimes happens, doesn't keep track of the time of day the transaction occurred, only has the date on which the transaction occurred. So I can't tell which transaction is the first one in the day, which one is the second one in the day. And I can't tell when I see a given customer's transaction, whether or not all of the transactions have already occurred on that day. So what I want is I want to grab all of the data up to the previous day. By being closed on the left and not the right, this is ignoring all transactions that occur are the most current transaction, only including transactions prior to it. So this works basically the same way as we used before, except excluding the current transaction. So I create that data frame. I grab the average value over the last 180 days, the standard deviation over the last 180 days, the total number of transactions of that product over the last 180 days. And because I need to keep track of what the product is, I just keep track of the product. Now, When I do this, because there will be multiple purchases of the product on a given day, I'll have multiple records with the same product and date, which I want to match back, join back to my original data set. So I need to drop my duplicates. Which of those duplicates do I want to keep? Well, I need to keep one of those. So I'm going to drop duplicates and keep the first one after having sorted by the total number I've purchased in the last 180, or total number that have been purchased in the last 180 days. So at this point, I'm holding a single record per product per day, and it's the first record from the, or it's built on the first transaction of that day and only includes transactions through the prior day. And then I just keep a track of all of those products. So we're just going through each product in the list and keeping track of what is the behavior of that product on a given day. So we can see as we run through this each day for product A, we see the count. We notice the first value is missing. We expect that. We're not including anything from that first day. As soon as we have multiple days, we see that build up. Now, I can merge that back in. Notice that we are merging on product and transaction day. And we can see we now have that product cost value being pulled back in for prior days. This was done at the product level that it was included in the transaction file. But I had categorical variables in the customer data as well. So I'd like to merge the customer data back into the transactions. And in this case, I'm going to use the state. And now I'd like to know, how does this state behave? Again, this is very powerful. It's a grouping of people that are probably similar in some way. I'd like to know how typical that customer is within that region. And we can do the same thing. So this is exactly the same code, only this time we're using the state. We're looking at all of the states. We're creating the same rolling window, the exact same way, exclude the earliest date, exclude the current transaction, calculate the mean, the standard deviation, and the number of purchases, keep the first one from any given date, and save it in the data frame. So again, this looks very similar. This time it's indexed at the state. You can make this as complicated as you want. You can get to the level of, I'd like to do the state and the product level. The only caveat is, make sure you don't run into such a fine dimension that you have only a handful of transactions. If you get to the point where I'm at the product postal code level, I may get to the point where I have a single customer in that postal code and it's just not meaningful. So be careful. You can actually add meaningless information. Think of it as adding noise to your data that's likely to just confuse the model, potentially cause problems. Okay, so at this point, we assume we've created rolling window values for the customer for all of their purchases in a prior time period, information about all of the purchases by all of the customers at a product level in the same time periods, and all of the purchases by customers in a given state in the same time window. we need to move that. We need to merge that all back together. So we're going to use pandas merge. I'm going to merge customer into transactions. We've actually seen this. This was done to create the state level data. We're just merging on customer IDs. In this particular case, it shouldn't really matter. You can argue that this should be done at either the customer level or the transaction level. I know my data is matched, so I'm keeping all my transactions. Next, to that existing data set, take that existing data set. This is the customer aggregation data. So we want to merge that back in on customer ID and transaction date. Then merge that existing data set, all of that, to the product that aggregations that we created, this time on product and transaction date. And then finally merge the state into all of that on the state and transaction date. And now we can see that we have a very large, very wide data set where we have up to here, everything to the left is information about the transaction. We see the customer information. And then we see information about the customer's aggregated behavior. Scroll down. Over to the left. Product aggregated information, and finally state aggregated information. So at this point, you could begin building a model. It probably wouldn't be the greatest model, but it would at least have some of that history that's necessary to build. For those of you who attended last week, you may remember this. Many models have difficulties when ratios are meaningful or differences are meaningful. And so it really helps to add interesting ratios and differences. So I said that last week, but I think a lot of times people say, well, that's interesting, but how do I decide? Do I just do all of them? That's insane. There's a massive number of possible differences and ratios. How do we pick? Well, let's think about this. Things that could be interesting. How does the current purchased amount relate to the average purchase amount for that customer over the last 180 days, right? This is just asking that question. So we can execute that. We could think of this as a different way. This was a ratio. We could ask the same question in terms of the difference. Or we could say, in addition to the difference between those two, I know what the distribution of their purchases look like. I know the standard deviation. So I could normalize that difference by the standard deviation. Now, it may be that the direction of that difference is important, so I care about the sign. It may not. I may actually be more interested in just the total different distance from the mean. So maybe I just want the absolute value. So this was done purely with customer behavior. But I have that same information for products. So how does this customer's purchase of this product compare with all purchases of this product in the last 180 days? We can do it the same way. So what's the ratio? What's the difference? Or I would think of this as a statistical distance. And then what's the absolute value of that? And then finally, we have the same thing at the state level. So how does the current purchase by this customer compare to all purchases in the last 180 days from within the state? So we can run that. We can take a look. And so now we begin seeing those cost ratios, cost distances, the absolute values for the various features. So before I move on to lags, I know there was a question about rolling. So I just want to take this as an opportunity to stop and re-explain rolling. So what I'm trying to do is create an aggregation of customer behavior, customer transactions in the past, right? The simplest way to do that would be to say, let's just take all prior transactions for a customer and aggregate them together. So what is the average amount the customer spent? What is the average number of products the customer purchased per transaction over the life of the customer? That's easy enough to do. We could just take that. The problem is that depending on how new the customer is, the magnitude of those could be very different between customers. If I have a customer who's purchased 100 different things over a 10-year lifetime versus a customer who's only been on for a month and has made 2 purchases. In addition, because of inflation, change in product mix, change in the company itself, products from 10 years ago may not be very meaningful anymore to the way the customer behaves. So I may want to pick a smaller number of those transactions and say, instead of what is the purchase, over all time, but what does the purchase look like in a given time frame? And so what rolling does is rolling says, okay, you have a sequence of transactions. I'm going to create a rolling window of a fixed size. So in this case, for each transaction, it creates a rolling window of every transaction that occurred in the last 180 days. So if there was a transaction on the 1st of January, there would be a window including all transactions from the 1st of January back 180 days. If the next transaction was on the 1st of February, that transaction would have its own rolling window, including all transactions going back 180 days, or roughly a window that's moved forward 31 days because of the change in date from the 1st of January to the 1st of February. And then once I have that group by, I can apply standard aggregations in pandas to calculate what's the average value, what's the standard deviation, what's the minimum, what's the maximum. So that's how I build up the customer data. And then I see a related question, the product and state level, the first row was missing. That's because I don't know when a given transaction comes in. So I'm choosing to say, I'm not including transactions that occurred on the same date because I can't be sure I will have seen them all when I calculate it in production. So I'm deliberately stopping that rolling window a day before. So it's 180 days up to yesterday. Well, in my very first transaction for a product or for a state, there are no transactions in yesterday or before. Well, if there are no transactions, it's going to be missing. So that's why it's missing. That brings into a question, what do you do about missing values? In this particular case, since it's the very first transaction, I'd be inclined to just exclude it. I could roll something back. One of the actual questions you have to answer here is, if I'm building out to 180 days, do I really trust anything I've calculated in the first 180 days of the data? Or do I use the first 180 days to build what I'd call my signature for my customer, and my signature for my state, my signature for the product, and then exclude any transactions in that first 180 days from modeling to say, I just need to calculate that for all of these. I'm going to ignore them from modeling, use them to build my features, but not use them to build my modeling. Okay, so right now we have data that has a time series character, but it's not a time series problem. But still, oftentimes the best predictor for the next behavior is the current behavior. And so I'd like to build up, how does this customer behave over time? So I'd like to take, for this individual customer, I'm going to group by this customer. And then I'd like to go grab, what did this customer look like in the prior transaction? So I have the current transaction, all of those features we just created. And I'd like to go look at how much did the customer purchase in the prior transaction? And when did that purchase occur? So what is the date of that prior transaction? So we can grab that lift or that leg through the use of shift. I'm going to shift one, so I'm going to grab the prior version. And then I can do some interesting things with this. The first thing is how long it's been since the customer last purchased is interesting, right? As customers lose interest in your company, it may be that they purchase less frequently. It may be if a customer has some sort of contract with you, say they use an Amazon Prime subscription or Amazon Prime subscription model, and they're thinking about canceling, they may actually speed up their purchase to take advantage of it before they stop paying for it. So understanding how long it is between purchases can be useful. So we take the difference between those two dates. I like it just as a number, so I'm going to take the number of days. So we calculated that difference, I called it the distance in cost over the average over 180 days. I'd like to know what that looks like from the prior day, or from the prior transaction, excuse me. And then I can look at deltas between those two. What is the delta between the current transaction and the prior transaction? Is it increasing? Is it decreasing? How is that changing? And I have this difference, the difference in cost, and I have this time difference. If I take the difference in cost and divide it by a time difference, as a physicist, this looks to me like a velocity. This is a spend velocity. So I can see how they're changing. Now, I think these spend velocities are really interesting. So I'm going to grab the value I just calculated from the transaction before, and I'm now going to create a delta between those velocities. So what's the current velocity and what's the prior velocity? Well, now I have a delta in velocities divided by a delta in time. This is the rate of change of the rate of change. That's an acceleration. So now I'm seeing how is that purchase trend changing over time. I don't know if this short of a window is really meaningful, but there's no reason I couldn't go back 2 transactions and do something similar, or 3 transactions and do something similar. So in this case, we're going to grab 2 ago, the time delta, the distance delta, or the distance leg, excuse me, and then the change in purchase from this transaction and 2 ago. calculate the same velocities. You can calculate the same acceleration if you want to. I have a slightly different velocity calculation this time. In this case, I'm calculating it over time. But I don't have to calculate time in terms of the time between two transactions. I can think of time as the number of transactions. This is effectively asking how has that cost changed over the last two transactions, or last three transactions, two ago. So there's lots of ways you can build up from what we've already purchased to get more and more information about how is the customer behavior trending. Now, at this point, you could go back and you could look at that rolling window I created to create the average purchase price over the last 180 days. And you could say, I wonder how the velocity has changed or how that ratio has changed. Do that same rolling window over these new aggregated features to create an even more complicated and hopefully more descriptive view of the customer's behavior. Okay, and then just because I think additional legs are always useful, I'm now going to grab 3 transactions ago and 4 transactions ago. And so at this point, I have the current purchase price or the current purchase amount, the purchase amount 1 transaction ago, 2 transactions ago, 3 transactions ago, and 4 transactions ago. And I could calculate it a weighted moving average. So in this case, I'm going to take the current purchase amount, multiply it by 5. I'm going to weight the prior purchase amount slightly less, multiply it by 4. Weight the purchase 2 times ago slightly less, multiply it by 3, and then by 2, and then by 1. And then the sum of 5, 4, 3, 2, and 1 is 15. So I'm going to normalize that whole thing by 15. And this is a weighted moving average of the last 5 purchases. And again, there's no reason you couldn't do the exact same thing with some of those other variables. Okay. So up until now, we've been building really with numerical values. And from a modeling perspective, we like numerical variables. They go into the model relatively straightforward. Maybe I need to standardize them. Maybe I don't, depending on the type, but they're pretty much ready to go. Most of the time when people talk about categorical variables, they talk about converting categorical variables to numerical variables. I'm going to do something completely different. I'm going to take a sequence of numeric variables and convert them to categorical variables. And what I'm going to do is I'm going to create a trend string. So I'm going to look at the customer's behavior over the last few transactions, and I'm going to create a string that tells me how the purchase amount is changing. How is the customer behavior trending? So the first value of the string, I'm going to replace with equal sign if the cost between the current purchase and the purchase 1 transaction ago is the same. I'm going to replace that value with plus if the current purchase is larger than the purchase 1 transaction ago, and replace that value with a negative sign if the current purchase is smaller than 1 transaction ago. And then I'm going to go on to the second character of the string, and I'm going to do the same thing, only this time comparing the transaction 1 ago to the transaction 2 ago. So if I don't have a transaction 1 ago, I'm just going to replace it with blank. And then here it is. If the current transaction is larger than the transaction amount 1 ago, we can replace it with a plus. If it's smaller, we're going to replace it with a minus. If it's neither of those, it must be equal. We'll replace it with equal. And then we're going to add to that string either a blank, a plus, a negative sign, or an equal sign, depending on how the purchase amount one transaction ago matches the purchase amount two transactions ago, and so on for the third character and the fourth character. So we're going to create a 4-character long string with this function. And now I can apply that string to this using pandas apply. It takes a little while to run, but here we see. So we have the cost. I don't have anything. Second transaction. Current purchase is 225. Purchase one ago is 300. String is negative. Next transaction, 150 is smaller than 225 is smaller than 300, two negatives. Oh, here the transaction is increasing. So we have a positive sign and two negative signs, and so on to build that up. And I just noticed a bug. The beauty of this, I don't know how I missed it. This should be grouped by customer. I'll fix that before I upload the data. Right now, this would cross over customer behavior. That would be bad. But this is how we can build up this trend string. Okay. So I'm going to go back because there's a question about 33. So there's a question about this multiplication. So I could create a moving average of simply the sum of each of these values divided by 5. But what that says is that each of these has equal weight. But do you think that the customer current purchase is more important to the customer's future behavior than their purchase 5 transactions ago or 4 transactions ago? I think in many cases, the current information is more valuable, more representative. So I'd like to give it more weight. So that's what we're doing, is we're weighting the more current information more heavily than the information from the past. And I'm simply weighting it in this linear fashion. You could use a different weighting if you wanted to. This is pretty standard for weighted moving averages. So that's why I'm using that multiplication. Okay. So there was the question that just popped up, which I was going to get to, but thank you for looking at that. This is, I just created a categorical variable, but most models need numerical variables. So what am I going to do with it? It's a really good question. This was added for 2 reasons. One, this can be a very, very powerful way to capture trends. It can be very powerful in the model. But 2, as I went through the presentation last week, I wasn't covering categorical variables in very much detail. But there were a lot of questions about what do I do with categorical variables. So let's talk about what to do with categorical variables. The first thing is you can, of course, treat them the way I did before, where I'm going to replace product with the average purchases of that product up until that date. That's okay. That may not be the most satisfying. I would absolutely do that. Don't get me wrong. I'd absolutely pull that in, but I may want a more pure way, more direct way, if you will, of pulling in that information. So how do we encode categorical variables? The first thing we need to do is we need a target. This isn't really that important, how I go about doing that. This is simply saying, I'm going to look at what date at which the customer churned, what the current transaction date is, calculated days to churn, and then I'm going to calculate churn if the customer churns within 30 days of this transaction. So we're going to define a customer churning at a transaction level of whether or not the last transaction occurs in the next 30 days. So that could be the current transaction is their last transaction, or that could be 2 transactions ago. They'll have at least one more, but they'll be done within the next 30 days. So I'm just looking at those customers who churn. So we can see the churn date. We can see we're within 30 days. All of those are marked. Okay. Not really relevant to this. It's not a feature engineering process. It's just how do I define churn? I'm going to create a train test split because I also need to do this when I calculate my features. I can't use stratified sampling. I can't use just traditional cross-validation because time is meaningful. If I just randomly select transactions, I could have one customer, their ending data in training and their earlier data in test. That's problematic. There's some information leakage. You most certainly will not get a good estimate of model performance on unknown data. So I want to split by date. So I'm just going to pull the minimum and maximum date in this data. Starts in 2017, ends at the beginning of 2020. I'm going to take 80% of the data to be in training and the remaining 20% to be test. So I'm going to calculate my train cutoff date as 80% of the way between the minimum and the maximum. So that happens to occur towards the end of May 2019. And now I'm going to split my data based on that date. So we can see what it runs from and to. Okay. Standard way. The thing you're taught very first when you've got categorical variables, one hot encode. So I have a number of features that I could pull in. Product only has 4 or 5 levels. Gender has only 2 levels in this data set. But city, state, all of these others have many, many levels. So let's one hot encode just product and gender. So I now have a data set that contains only 2 columns. I'm going to use scikit-learn's one hot encoder. I'm going to ignore unknown variables. You can look up what that means. I'm going to take my training data set and I'm going to fit the one hot encoder and encode the training data all in one step, save it. And I've gone from the 2 columns, product and gender, to 7 different columns. So for each level of product, I have 1 column, 1 if it's that product. So product A, column A will have a 1 if it was product A, 0 if it was product B, C, or D. Column B will be a 1 if the product was B, 0 otherwise. We can one hot encode that. And then we can use this one hot encoder to transform that test set. Again, not surprising, get the same 7 columns. This is great if I have very few columns or very few levels within my categorical variables, product or gender. There's only a handful. It doesn't explode. I could merge this back into my original data, replace product and gender with these one hot encoded dummy variables, build my model. Okay. On the other hand, that cost trend has lots of different values. There is no way I'm going to want to one hot encode that. I'm going to blow up the total number of variables in my data set. So the same thing is going to happen for city and state. So in this case, I'm just going to pull in city and state and look at a training and test set. So here I only have three features. And in this case, I'm using that category encoders package. So you can pip install this into your environment. There's two that I would look at. I'm using leave one out encoder. There's a very similar one called target encoder. They work very similar. You can choose which one you use. What leave one out encoder is going to do is it's going to look at, okay, for this transaction, I have a given value of city. What I'm going to say is, okay, take all the transactions in the training data set where that city is the same as this current city, ignoring this transaction, leaving this transaction out, and take the average of the target variable, in this case, whether or not it churned. So I'm going to replace a given city. I live in San Diego. I would replace San Diego by the churn, the probability of churn for all transactions that occurred in San Diego in the training set, except my current transaction. That's what leave one out is doing. So it's going to replace it with a probability. And so if we run this, we see we don't have an increase in the number of features, but we have converted from a categorical variable to a numeric variable at this point. And I can do the same thing on the test set. We can take a look at that. And so you now see the values that appeared for each of those. So last thought, and then I can take a few questions. The first thing people are going to worry about is I'm now using the target to create a feature, which is true. Something you're oftentimes told not to do, with a couple of caveats. I'm only evaluating my model in a test data set, but I'm only using target information from the training data set. Even in the test data set, that's being replaced with a value I already know from the training data set. In addition, in the training data set, I'm not using the current transactions value. I'm explicitly ignoring it and only using the other features. There is a small risk that you can have overfitting, but because of that care and because you're always evaluating model performance in that test set, the risk is relatively low of overfitting. Okay, so at this point, you should be able to put all of this together, build a complete data set with lots of features, and actually predict churn. Okay, and so there is a question about how to handle the nans created during lag features. There's a couple of things you can do with that. The first thing I would do is I would prime the system. As I said earlier, if my biggest window is 180 days, the first 180 days of my data would be used to calculate features, but then I would drop from modeling. Okay, so that gets rid of the vast majority of those missing values. But what about new customers that are coming on? New customers in their first transaction will have missing values. Some customers transact really, really rarely and won't have gotten to 4 transactions by the end of the first 180 days. They'll have missing values. There's a number of things you can do. You can replace it with a meaningful value. If you know that no transaction has occurred, maybe you replace it with 0. I know that there was no transaction, so I don't have a problem replacing it with 0. Maybe I replace it with the average value or the median value, very standard way to do it. Maybe I take an earlier or a later value and propagate it forward or backwards. I would try a number of those different techniques. I'd start with, I know it should be missing. Maybe I just pick 0, go from there. And then I would try some of those other techniques. One thing I would always do is if I'm imputing a missing value, whatever method I use, I'm going to also create an indicator value that tells me whether or not that value is missing. So if I have cost leg 4 and I've imputed missing 0, whatever it is, I'm going to create a cost leg for missing variable that's 1 if I replaced a missing value and 0 if I did not. The reason I'm doing that is that missing value may be more important to the model than the actual value is itself. So we handled that. So this is a good question. This is one of the challenges of leave one out encoder and also the target encoder. What happens if the cardinality of train and test set is different? If the train set's cardinality is larger than the test set, that's fine. Right, it's covered as long as the test set is a subset of the train set. We don't actually have an issue, except if I have very, very few observations for a given level. So what you may want to do is actually modify this slightly to say, okay, I'm going to do leave one out encoding if I have a large number of observations. So if I have 50 or 100 observations of that level, I'll replace with the current value. If I have 10 or under, I won't replace with that value. And then what I may replace with is just the population average. And then going forward into that test set, I would use something similar. I would say, okay, if I was replacing it in train with this value, I'll replace it in test. If I haven't seen it before, if it's a new level, I don't actually know what to use. I probably replace with just the population mean. So that's how I would handle that. Good question about target encoding with only previous target values. Absolutely, you can do this. I'm not aware of a package that does this, so you would have to use some sort of approach similar to what I've done to calculate the running average to the current time to do some sort of target encoding. And then you've got all sorts of flexibility to be able to say, do I have enough observations to trust this? And do I want to use some other value? And then Subramanian about this data, you could absolutely look at products. You can't actually answer the question you want here. You'd have to generate some additional data. So you're asking about, can I identify products that aren't generating profit? Because I didn't create product level data about what's the profitability of various products. It's not something you could do, but you could absolutely generate that data set and then look at product level instead. Okay.
I think actually there are a couple of questions in the chat window as well.
I see a couple of them. So I see a couple of questions. There was one about what do we do when we have so many category values in a categorical column? That's the purpose of this leave one out or target encoding, is that I don't have that explosion in the number of dummy variables. There is a concern about target-based encoding leading to overfitting. The real key here is only calculate that target value on a training set and then go do your evaluation on the test set. And so, yes, there will be some overfitting, probably small if you have a very large number of observations in the training set within the training set. But since you're evaluating that performance on the test set and those target variables are taken from the training set, not the test set, you're at a much lower risk and you know how that model performs on new data. So it's possible there's overfitting, but you will see it because you're evaluating on that new data set. And then a very good question about these features. How do you do this in production? A lot of this stuff can be done in an Airflow job. As data comes in, you can build these features in Python and serve them directly to the model. So this would be part of your production pipeline to generate these features as you go. One thing I would say is I won't generate these for all transactions. I'd only grab the current transactions, and those lag variables, I may already, I calculated the last time the customer transacted, I just saved those. So those lag variables I just pull from a database, but everything else I would calculate for the current transaction as that transaction comes in. Yeah.
I think, Andrew, there was another question on earlier in the code, you used the value of 0.8 and how you arrived at that value.
So this 0.8?
Yeah,
I think that's it. It's just a rough value. Oftentimes when I do training and test, I take about 80% of my data and use it for train, and the remaining 2% or 20%, excuse me, as test. Honestly, what I would probably do is about 60% for train, the next 20% for test, and I'd have a final 20% holdout, again, as a absolute last check against that overfitting. So train my model on the first 60% of data, all of my evaluation, model selection, everything I do on the next 20%. When I'm all the way done, take that model and evaluate it on the last 20%, just as a final check to make sure I'm not having any target leakage. But 80% is just a rule of thumb I'm using in this particular case. And validation set, test set, validation set, it's the same thing. It's just, you call it train test, or do you call it train validate? The language behind these sets is confusing depending on where you come from. Okay, and so training data, we create a feature using target, but without using target and test. By using the target value we calculated from training. So in training, I take the training average, use it in training. In the test set, I use that same average calculated from training. So I need to store that information to use in tests. And that's exactly what happens here. So this effectively fits this encoder using just the training data. And then it uses that transform, that encoder, the information learned in training on that test set. So there's a question about lags. I don't have a good rule of thumb for the number of lags. You need to look at the data. How does it change? How relevant is it? How long is the time scale? You know, is 4 transactions 2 years ago and I'm making a prediction in the next 30 days? 4 is probably way too large. You just have to look at that, and it's getting a sense of what scale works. And then the other thing is there's a huge amount of art here. So you need to try a wide variety of things and pick the one that works best in that modeling. There are other questions I may have missed in the chat. I think I've captured the ones in the Q&A.
Yeah, so I think there was just one question about when you use the one-hot encoding, there was a question of what if we use label encoding, encoding these categorical string values, and then we can bucket them according to the patterns in there.
Can you say that again? I'm sorry.
Sure. So when you did the one-hot encoding, there was a question on what if we had used label encoding to encode the string patterns that you had generated, and then bucketing those string patterns into to create a different type of a categorical variable, say a bucket or something like that.
I mean, it's absolutely possible. I don't think you even need to necessarily do that label encoding first. You absolutely could generate clusters of that pattern to say these clusters behave similarly, however you want, purchase amounts, product types. There's lots of opportunities to create clusters, pulling them into smaller sets, and then either one-hot encoding those higher level clusters or leave one out encoding those higher level clusters. And it's not just that trend string. That actually works at lots of different levels where I have lots of different products. I can cluster them together either using data science, or I have higher level product information that these products are all the same kind of product. I'm going to cluster them that way. Absolutely, you can do that. And there's a lot of value in using both of those techniques.
Last couple of questions, Andrew. So there's been a question as to the final output that you get in the end. If you could explain what the output is, like when I think that is when you created the based on the customer behavior, the final output.
Yeah, so I'm only looking at a handful of these. Actually,
no, I think the last line in the code in the notebook.
So all we have here is this information, the city replaced, the state replaced, the cost trend replaced. I would need to append this onto that. Make sure I get the right one. Trend data. So I have this. You notice the index, I haven't done anything to the index. So I could merge this in with this to replace city, state, and that cost trend. And then I would have that modeling ready data set. So I would need to pull this information into all of the other features I created. And then I just have a flat file ready for scikit-learn, XGBoost, whatever your favorite modeling tool is.
And there's one final question. I think you'll be very interested to answer it. So this person Preeti is asking, what does Rasgo do?
Yeah, thank you. I didn't want to have to sell, but someone now asked. So Rasgo is actually focused on helping data scientists do feature engineering at scale. So there's two pieces of our product. The first part is there is a Python package called RasgoQL, RASGOQL, and that's an open source package that you can write in Python, and it will execute SQL for you in your cloud data warehouse to do these sorts of transformations. So instead of you needing to write SQL to build this rolling aggregation, like I did way up here, wherever it was, way up here, instead of doing that, you can simply call a function in RasgoQL and it will connect to your database and it will execute the necessary SQL to do that, and then allow you to chain this all together. So that's just an open source package. It's in alpha right now. It will be released in the next couple of weeks to support Snowflake, BigQuery, and I believe Postgres. So that's one piece. Open source, you can download it. You can give it a try, just RasgoQL. The other piece is an enterprise product where, in addition to those capabilities, we create and manage the data storage so you can serve those features to production. So build the features, store them in SQL, and then very easily serve them out. So if you are interested and you would like to know more, you can always find us rasgoml.com. So you can find the information about how do you generate those features, how can you generate them quickly, and then how do you serve them? Okay.
Awesome.
Well, thank you very much.
Yeah, thanks so much, Andrew, for the amazing session. It was great coding along with you. Even I coded along with you, actually. So guys, there's a feedback form for this session. Please make sure to fill it. It helps us make your experience better. Right. And thanks for taking out time, Andrew, in your busy schedule to have 2 really amazing sessions for us. Just as a reminder, both these sessions will be shared with you guys along with the files and the notebook that has already been shared. And thanks to all the attendees as well for being so active in asking questions and participating in the workshop as well as the previous session, and for attending this session as well. Thanks, and have a great day.
Thank you all.